How about for n equals 3? So for n equals 3, the subgame that follows the history of, so for example, if player 1 takes one bomb, then you get an n equals 2 game where player 2 is the first mover. Does that make sense? So it's n equals 3, and if player 1 takes one bomb, then you have n equals 2, and then because it's player 2's turn, now you have an n equals 2 game where player 2 is the first mover. Therefore, player 2 wins. Okay? So if player 1 then takes 2 bombs, then you get an n equals 1 game where player 2 is the first mover. And again, player 2 wins. So there is a subgame perfect equilibrium where player 1 takes either 1 or 2 bombs and player 2 wins. How about if n equals 4? So the subgame following player 1, if player 1 takes 1 bomb, we get a game where n equals 3 and player 2 is the first mover. Okay? Therefore, player 1 wins. This is exactly like the n equals 3 game where player 1 was the first mover and player 2 won all the time. So now if you're n equals 3, if you have an n equals 3 game and player 2 is the first mover, player 1 wins. So if player 1 takes 2 bombs, then you have a n equals 2 game where player 2 is the first mover. So player 2 wins. Therefore, because player 1 taking 2 bombs becomes an n equals 2 game with player 2 as the first mover and player 2 automatically wins, player 1 will always take 1 bomb because taking 2 bombs is not a best response. Therefore, in every subgame perfect equilibrium, player 1 takes 1 bomb initially and wins. Okay? So continuing this argument, for larger values of n, we see that if n is a multiple of 3, Okay? If n is a multiple of 3, player 2 always wins. While if n is not a multiple of 3, player 1 always wins. Okay?